So, welcome back. Now, in the last video, we extracted a time series of PC1, which explains 45% of the variance of the EU blue chips. And now I raised the question about, can we give some meaning to that black box factor, right? And wouldn't it be nice if that factor correlated strongly with the market portfolio? Then we would be back in this idea of a CAPM idea, that there's some market risk, which is something that you could proxy with a market portfolio, which in our application would be the 1/n portfolio. Let's just do it. And while doing it, you also learn something about how to run regression. It would be our second application of how to run a regression. So by now you should know it if you follow that COVID tutorial at home or you've practiced yourself. You already know it. Lean back. There's other stuff going to come, maybe, hopefully. Let's see what time brings us. So for the moment, we just want to think about, let me give you a nice headline. How similar is PC1 to the equal weight portfolio? Okay. Any guess? I can't hear you. So that's the disadvantage of the recording, right? But just think about what's your prior that you have about that. All right. Now, what do? We run a regression, so we don't code it ourselves. We just use a package we already loaded in, the stats models package in one of the other videos. Okay, I don't want to go all the way back. So we just reuse it, right? So what we now have to do is we have to set up the regression. In order to set up the regression, we need our supervisor, the y variable, and we need our feature, the x. So it doesn't really matter whether we regress PC1 on the return of the equal weight or the other way around, since regressions just capture a correlation and not causality. I do the standard thing. Basically, I ask myself, how much of the PC1 variation is captured by the market portfolio? Okay, don't talk, just do. The stats models was called stats. Let me double check that. Where is that? Yeah, I should have maybe saved it up front. We have the equal weight portfolio. It's part of RD. That's good to know. And then, come on, I just want to know what's the here. Stats models RP SSM. All right, so that is the regression package that we use. And I think what I was after. Okay, just stealing your time, Here. We also use the stats package because I want to, since I know the PC is not unique, only up to an affine transform, I want to work with the z-scores. So X will be my z's and my stats that has the function z-score, and now give me the z-score of the 1/n portfolio. Here you get it. And I also want to add a constant as a feature. Yeah, so that's my regression package from the stats model. It has this function, can you remember? Something like add constant to what? To my x feature from above. And what's my supervisor? The y, that would be the PC1. Now the PC should already be normalized, but I just want to be sure. I just want to be sure. Even if it wasn't, now it is. Okay, great. So that's what we have. Boom. And now we want to run a regression. And for the regression, we use the stats model package. So we run a GLS, generalized least square. We don't want to make the assumption that the errors are IID. So we run a GLS regression of PC1 on the equal weight portfolio. All right. And the way we do that is we have our stats model. It has the function GLS. And it wants us to read in the supervisor and the features. The next thing it wants us to do some fitting. Yeah? So we fit PC1 on the equal weight portfolio. And that is our object, which we just defined previously. Dot fit. Okay. Boom. And let's look at the regression table. Okay. So we just say fit, or shall say print fit PC1 equal weight. Dot summary. That gives me the summary statistics basically of that regression. And what do you see? What do you see? You see that first, Y is regressed via GLS. We have 5,380 observations. The R square is 99.6%. That says, let's be a bit generous. The 1 over the portfolio, the return of the 1 over n portfolio just coincides with PC1. Check. It couldn't have been better. Because we extract from a statistical concept one factor out of a panel that maximizes variance explained. And now it turns out that factor coincides with the market portfolio. Good stuff. Why good stuff? Because we saw that the CAPM doesn't hold in our data. The market premium is negative that we estimate. We also saw that there is no positive relationship between beta and the average returns, which is exactly the same as I said before, that we have a negative relationship, so it's a negative risk premium. That is a bad thing. You would really think about throw the CAPM out of the window. Now I say, wait a minute. CAPM is CAPM. It's a theory. It's nice for thinking. But now we are in the data part, and we found a low dimensional representation of the panel. Just one factor explains 45% of variance. And we even found that that factor has a nice interpretation, which every market participant understands, just the market, right? And then what about this negative premium for that thing? Guys, we just used 42 stocks. And I think we can do better in terms of having more data and in terms of using better ways to measure the betas, right? So therefore, not everything is lost as of now. So there's hope. But I like that very, very much. And what else do we take from that regression? Oh, I look here. All right. You see the coefficient is negative. I knew it. When I looked in my last video and I started to stumble about the PC1 is not unique, but just to an affine transform. I was like, what the heck am I telling you here? But I had the feeling looking at the PC1 plot here that I have to multiply it with -1. And I got unsure because of the crisis here, but I thought here that was the COVID hit. It went down first and then it went up again. And then I think that was the recovery. And that's why I had a feeling it's a multiplication by -1. And here's what you see, right? The regression loading is really -1. And look at the T statistic. That is to all my friends and one of my previous PhD students who showed me stuff with a 1.6 T statistic. And didn't want to believe me when I say, listen, if something is significant, it is really significant and not just close both eyes and say it's marginally significant. I mean, something which is significant is significant. We have a T statistic of -1,200. Take that, statistics teacher. What does it just tell me? If you look at the confidence interval of the coefficient estimate, it just tells me I'm pretty sure it's 1. I'm pretty sure it's 1. Nice, nice. Okay, great. So I like it. I like it. And I think we have to redo it for the US because in the US we have roughly 500 stocks. And I just want to know, is that the same for the US? I also want to know whether these two factors kind of co-move. And there's some other stuff I want to know. So guys, you want to have some problem sets, you want to practice, just do it yourself. And I'm going to post that. I don't know when, but I'm going to post that. So if you get stuck somewhere, then just follow what I do. Otherwise, enjoy. I think that will be interesting. All right. So, talk soon.